Hello everyone, I am Panupun Janin and today I will present you about the digital twins. What is digital twins, and I will introduce it with the real world applications. So, digital twins are becoming some kind of important aspect in different industry, helping businesses, government, and researchers to simulate and predict, of course, improve the performance of physical systems without needing to experiment it in the real world. So how does it work? First thing first, I need to explain what is the digital twins. A digital twins is a highly detailed virtual replica of a physical object, system, or even a process. It will receive continuous real-time data from the physical counterpart through some kind of data source like sensors or IoT system. And this data-driven connection enables the digital twins to simulate the behavior, performance, and conditions of the real-world entity it represents. And of course, this model isn't static, as it will evolve and update alongside its physical twins counterpart, becoming some kind of powerful tools for monitoring, diagnostics, forecasting, and optimizations. If you don't understand yet, you can think of it like the Google Map. The Google Map for a machine or system, instead of just seeing a picture, you also got a real-time movement, traffic, weather, and rerouting method suggestions. But in the digital twin case, it might not be for the maps like the Google Maps. It might be for the jet engine, a city traffic system, or even a hospital patients. Okay, so the core components of the digital twins, first thing first, of course, the physical entity, right? This is the actual real world asset or system being mirrored, such as the wind turbine, factory production line, or hospital patients, as I suggested earlier, or even an entire city. The goal is to understand its behaviors and predict issues that might have happened, and also improve its performances. Next is the digital replica. It's the replica of the physical entity, but in the digital form. And this is the software model that will simulate the physical twin's behavior as it uses data or historical records and simulations, and of course AI right now, to replicate how the real world entity functions and responds in different scenarios. Lastly is the middleman of the two above, the data connections. This is the middle part that link the physical and digital twins. It typically involves some kind of IoT sensors to collecting data like temperature, humidity, speed, or even pressures, or the communication layers like cloud networks or edge computing to be able to store the data that we get from those sensors and update it as a real-time data. Next is the real-time data analytic for processing and visualization as the digital replica, of course. So, how digital twin works? This will be a step-by-step of how the digital twin works. First thing first, sensors and data sources will be installed on the physical system to gather relevant data, like vibration, energy use, or motions, or like you can imagine you're in the metro system, right? There's a sensor that detects metals. It will be sensor like that, but it will detect if you enter the building instead. It will be a sensor like that, first thing first, on the physical thing, the real physical real world thing. And next, after we use the sensor, the data will be transmitted, often in real time of course, to the digital twins, using the cloud platform or edge computing method. And next, the digital twin will update its models based on the data that it receives and run the simulation to evaluate performance and detect anomalies and also forecast future behavior. So, the last step, based on those simulation results, a recommendations or control signals can be sent back to the physical system for adjustment. It can be automatically done by system or even by the human decision makers. Like the metal detector that I said earlier, right? If some people carry metal or dangerous thing before coming to the metro, we need to have the security guard to protect others and remove those dangerous things from the system, right? This is also how it's work, but it by it works by simulating it. So we don't really have to have the real dangerous thing inside the real system first, but we can prevent and be prepared for it. Okay. So, as I explained earlier, next I will be showing you some kind of real world applications. The real world applications of digital system is a lot. There's a lot of use cases for digital twin in real world applications. And these are some examples that will give you better understanding or better ideas of how it works and how it will benefit us better. Okay, first example is from General Electric. It is the topic of smart manufacturing and industry. The digital twin will help factories become smarter and of course more efficient. That simulates production lines, monitor equipment health, and also automate maintenance decisions. For example, like I said, General Electric or GE, this use a digital twins to model their jet engines. By tracking engine performance in real time, they can predict when the part will wear out, allowing them for maintenance before it becomes a real problem. And this of course will reduce unexpected failure and enhance safeties and save millions of dollars because you don't have to pause the process, but we can deal with the problem before it even happened in the real world. Next is an entire city that I said earlier. It is about the urban planning and the smart cities, like in the picture, the Singapore cities. The digital twin of the entire city will help urban planner to manage infrastructure and growth intelligently. Not only Singapore, but this can be also applied to the entire world, the entire city of the world. But I will use Singapore as the example right now because Singapore has developed a citywide digital twin called Virtual Singapore. It helps simulate emergency scenarios like some kind of flood because there's near the sea, right? And fires that might have happened because they're in the tropical areas. And they can also monitor the building energy usage and also optimize the traffic patterns that happen in their cities. That's the benefit of the smart cities, or we call it digital twins in this case. Next is a really high-tech one for me. It's about the healthcare system. The digital twin in the healthcare can simulate the human body and also the treatment outcomes based on the personal data of a patient. These personal data digital twins can be used for personalized medicines, even remote monitoring or the surgical planning. For example, some company like Siemens are exploring the use of twins for chronic disease management, and imagine having a virtual model of a heart to test different medication before prescribing them. Like imagine having yourself as a virtual digital one and having some symptoms that aren't really be able to detect by the current situation of your body. They need to be dissected, they need to have a surgical planning, something like that, before doing a real thing. But the digital twin can do all that. They can examine your body from the digital twins and just plan from that. Making plan from that first, then perform a real surgical procedure for your physical self. And of course, the success rate will be a lot better because they are already tried in the digital twin, right? Okay, this is what I think that really benefit us. The next example is the energy sector. Like I said, Siemens earlier, they also do the energy sectors. Utilities will use digital twins to enhance energy production, the distribution, and equipment maintenance. For example, Siemens, they are using digital twin to manage wind turbine and also optimize the power grid operation. Like it can be forecast, the energy demand can be forecast, and the wear patterns, the wear out patterns. Of course, by this, they can ensure more efficient energy delivery and prevents blackouts. And like I said, the wind turbines, right? In different area, there's different wind force, and wind turbine will have different energy output as well. So the usage of digital twin here can be used to simulate which location will be able to have the maximized wind turbine energy output, and of course the wear out rate of it. We can test it in the digital twin first before implementing, and it can save billions of dollars of the companies, because building wind turbine is not something that's small. We can do all the testing, all the simulation in the digital twin first before having it done in the real time system. Okay, next is everything that you already know about NASA. They have a lot of high-tech technology. So I will talk the aerospace thing with NASA. Digital twins will allow real-time diagnostic and mission planning for complex aerospace systems. Like NASA, they use digital twins of spacecraft to model the system from Earth. Like the Mars rover also has a digital twin on Earth that helps simulate terrain challenge on Mars, and they can perform virtual tests before executing a real commands on the rover on the Mars. Because doing it real time, you can really test the rover on the Mars. If it's broken, then all of the budget will be gone. They need to send a new rover. So that's why the digital twins come in clutch and just help it all with the problem of they can test the rover on the Mars. Okay, next example is about the construction and real estate. Sorry. So in construction, digital twins will extend the power of building information modeling, or we call it BIM. You can search in the Google the keyword BIM, and they will model building health, the energy use, and they can predict future structural issues that might have happened from the stress on the iron, the stress on the concrete, something like that. Like the after building is constructed already, the digital twins of the physical buildings can track the temperature variations, the air quality, and the structural integrity. Maintenance teams can also detect water leaks or the inefficiencies in electricals before they can become real serious issues. They can detect it first, fix it first. They can detect it in the digital twin, right? But the physical one haven't have any problem yet. So they can detect that and clear the future problem before it become a serious issues. Yeah, let's also explain why do digital twins matters. So the digital twin matters because they enable smarter, faster, and more informed decision making by providing a real-time data insight into performance of physical system. Instead of relying on some kind of assumptions or delayed reports that will be made when observe the real physical thing, user can monitor and respond to the actual conditions as they happen. This is especially valuable for predictive maintenance, where potential issue can be detected and resolved before it's cause a failure, that lead to minimization of downtime and saving a lot of operational cost. By simulating the scenarios in the virtual environment, organizations can also reduce risks and avoid dangerous or expensive mistakes in the real world. Additionally, the continuous feedback loop of digital twins helps optimize products and systems over time, leading to improved design, also reduce waste, and greater efficiency overall. And finally, the digital twins support the entire life cycle of an asset, from initial design and testing to real world operation, and eventual retirement. This ensures the performance and value to get maximized throughout the process. Okay, next, the last topic is about the future trend of these digital twins. First, the AI powered twins. There's also a lot of experiment going on with this AI powered twin. Like the digital twin that will increasingly use AI, of course, because is already improving, right? The AI system right now, they can use it to automatically learn from the data and make decisions on their own without human interventions. And this will lead to self-healing system and smart automations. You can use it like on the irrigation system of farms or something like that. That AI can decide for you what is the best for the plant, right? And next thing is the thing that I say that will benefit us the most, in my opinion, right? The human digital twins. So imagine a digital twins of yourself based on your own medical data and lifestyle genetics, and also your habits. This could be used to predict your health risks, and of course guide your nutrition plans, or even optimize your fitness routine. Not just that, they can also help the doctor to analyze you faster in case of something happening to yourself. And lastly, about the metaverse that you might already see is on the internet. The metaverse and simulation training, the digital twin could be the part of metaverse, like the real cities for the pilot to try to train. It will enable realistic environment for training pilots, of course, doctors on the humans, or emergency responders. And this immersive simulation will also offer hands-on practice without any real-world risks. Like a truck driver that needs to ride around the town, they can also ride it in the metaverse system. They can do all that, they can practice in all that. If they crash on the system, it will affect their score, right? But it will not cause any actual casualties. So this trend is really interesting to me. Okay, before anything else, I want to show you the Google Maps that I say. About the Google Maps, that's it. That I say that it is also some kind of digital twins. It will show all the maps that happens, like the Kasetsart University, for the subject that I am presenting for this video, right? You can see that all the roads inside, you can see the stadium, you can see any kind of tower, any kind of buildings that are in there. And not just that, it makes of digital twin because it can also give you some kind of real-time traffic, like this thing. You can know the real-time traffic. This is real-time, right? If you open the app and play it, this is some kind of digital twin. It can help you predict what route should you use. Like if you are going to use this route on the road will be longer than expected, so you need to prepare more time of it. Or the green route, that might be faster because there is no car in sight. Or you can decide to use the public transportation like the BTS or the SkyTrain to avoid all of the traffic jam altogether. Yeah, so that's about it for me. That's the future trend, and the current trend, that current digital twin that everyone has access to for me. So, thank you for your attention. That is all from Digital Twins, and I am Panupun Janin signing out. Thank you for your attention.